Alright, so we have section 6.9. This one's just more proofs, just has a little bit more blanks in it. And has some fill in the blank stuff in there and drag and drops, but I'm gonna use them, fill them out if they don't have them. Right, so first things first, it has that these JL and QS are parallel, and that KRS, KRS, so this angle, so this blue angle here, and LKR this are supplementary. So let's say that blue plus red equals 180. Okay, so these two are here are supplemental. Alright, so first things first, I'm gonna this thing here is already given. And then I'm gonna say, I'll put my other one in here, that an angle KRS S and angle LKR are supplementary. I'm gonna put that on. I'm gonna put that here. Angle KRS is supplementary to angle LKR. Save myself a spot. It's all one given statement. Why not? Alright, so I also have, because these two are parallel, let me extend these, okay, just like with dotted lines to help paint a better picture. Whoops, a better picture here. That one and this one. Right, I would have, and then I'll extend this, what would be a transversal further on through this. Oh, that's really rough. Okay, that is my transversal, right, through those two there, right? So I would have this angle and this angle being shared by these two big triangles here. This big triangle and this triangle and this triangle, the two that we're trying to prove, JKL and QRS. They would both have these two congruent triangles because these two triangles are corresponding angles. Right, so I'm going to say that triangle J, that's not right, angle LQL JQ is congruent to angle SQR. Angle SQK, whatever, because corresponding angles are congruent. Alright, so now I'll just kind of get rid of that. Okay, so you guys can see some more stuff here. Okay, so now I have these two here. So I have two angles already, right? And if these two are supplemental, right? I know that this is a linear pair, right? And if I know that I have that angle, I'll say that angle Q, I'll say that angle, I'm going to say that angle QKL and LKR LK angle LKR are supplementary. Because they are linear pair. Okay. Yep, because linear pairs are supplementary. So I'm going to say that angle LKQ is congruent to angle KRS because of the congruent supplements. Because supplements because just a second, I gotta remember. Because the supplements of the congruent supplement theorem is what's called. It's just called the congruent supplement theorem. Congruent supplement theorem. And then because of that, I have two angles of the two different triangles that are congruent. I have this one here and this one here. And then I can say that the triangle NKL is similar to triangle CRS because of the angle similarity. They did it a different way, which is fine, right? They said that because these two angles were supplementary, that KL and RS are parallel because they're consecutive interior angles, right? These would be consecutive interior angles, and if they were consecutive interior angles, which they are, and they were supplementary, right, then these lines must be parallel, right? And then if these lines were parallel, then you'd have these two, angles. They would have to be congruent. I like my way better, because that's the way I figured it out, I guess. Okay, then there's this one. This one has numbers. Right, and I think it's a little less, what's the word? I don't know if I'm going to have time for this one, but we'll try. Okay, so you have EF. EF is, everything's labeled here. Okay, so EF, over R over EG or over EG equals 6/15, and you have IG over wait a minute, I don't know if that's right or not. That's not right. You're gonna have to have, that's not right. It's gonna be FG over EG is gonna be equal to, should be equal to something, and then it's gonna be HG, that's your small triangle, HG over IG equals something, right? And those should be equal to some similar thing, right? So FG is 15, EG is 21, HG is 10, IG is 14. Right, so 15 divided by 21 equals that 0.714. Is that a fraction decimal? It's not. And then 10 divided by 14 is the same thing, both approximately 0.714. And that's the division property of equality. Division property of equality. Therefore, you have that both those fractions or those proportions, f g or e g, is equal to h g over I g, and that is the substitution property of equality. And then you have this angle that equals itself, so you have angle HGF. HGF is congruent to angle IGF or IGE because of reflexive property. So then you have a side, another side that are similar, and the angle in between. So you have angle or triangle EGI, which is congruent to angle FGH, not congruent to, similar because of side angle side similarity. Hope that helps. Time for class.